Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this video, we will learn the gateway routing design pattern for microservices. Yes friend, I'll explain you what is gateway routing design pattern. I'll explain this design pattern with the real world examples. Later, we'll understand the use cases and benefits of this design pattern. Friends, in the previous video, we discussed about proxy design pattern. Can you explain what is proxy design pattern? Please provide your answer in the comment section of this video. If you have not seen that video, so please go and watch that video. The link is provided on your screen and also given in the description section of this video. So for more information, go and watch the previous video on Code One Digest channel.
We have an agenda here, Daniel. It's really very simple.
Friends, here is the agenda of this video. I will give you the introduction of gateway routing design pattern. Then we'll see the real world examples of gateway routing design pattern. Then we'll understand the use cases and benefits of gateway routing design pattern, the scenario where we can use the gateway routing design pattern. Then later I'll summarize what is gateway routing design pattern and what we learn in this video. So stay tuned till end of this video. It is going to be very exciting and it is going to be very informative. So keep watching Code One Digest. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share, and subscribe my channel so that I can grow Code One Digest family. Thank you.
All right, let's get started.
Okay, friends, so now let's start with the gateway routing design pattern. Remember, this is the fourth design pattern in integration design pattern category for microservices. Gateway routing pattern is a route request to multiple microservices with exposing a single endpoint. What does that mean? For all your consumer, it is going to be a single API of your gateway, and then gateway routes your incoming request to respective microservices or endpoints. So all the communication to your microservices is via this gateway. This pattern is useful when we want to expose multiple services on a single endpoint and route them to internal backend microservices based on the request. The pattern is useful expose multiple microservices on a single endpoint and route the request to an appropriate service based on certain logic. Route the request to multiple services or multiple service instance using a single endpoint. Expose multiple service on a single endpoint and route to the appropriate service based on the request. Expose multiple instances of the same service on a single endpoint for load balancing and availability purpose. Expose differing version of same service on a single endpoint and route traffic across the different versions. Client application only need to know about the single endpoint and communicate with the single endpoint. Let's understand the problem first. When a client needs to consume multiple services, multiple service instance or a combination of both, the client must be updated when services are added or removed. Example, an e-commerce application might provide a service such as search, reviews, cart, checkout, and order history. Each service has a different API that the client must interact with, and the client must know about each endpoints in order to connect to those services. If an API changes, the client must be updated as well. If you refactor a service into two or more separate services, the code must change in both the service and the client. You can place a gateway in front of set of applications, services, or deployments. Use application layer 7 routing to route the request to the appropriate instances.
Sounds good, man. Sounds good. Good plan. Good talk, all right?
Okay, friends, now let's understand some important features of gateway routing design pattern. We can use the gateway for the multiple purpose. We can expose multiple services on a single endpoint and route to the appropriate service based on the request. We can expose the multiple instance of the same service on a single endpoint for load balancing or availability purpose. Expose differing version of the same service on a single endpoint and route the traffic across the different versions. Client application only need to know about a single endpoint and it communicate with a single endpoint. Let's understand the problem. When a client needs to consume multiple service instance or a combination of both, the client must be updated with the services are added or removed. Example, an e-commerce application might provide a service such as search, review, cart, checkout, and order history. Each service has a different API that client must interact with, and the client must know about each endpoint in order to connect to the services. If an API changes, the client must be updated as well. If you refactor a service into two or more separate services, the code must change in both the service and the client. So you have to place a gateway in front of all your application, services, or deployments. Use application layer 7 routing to route the request to appropriate instance. These are some important features of gateway we can leverage in your scenario. Let's understand this design pattern with a real world example of e-commerce application. Let's say you have an e-commerce application might provide services such as search customers, shopping cart, discount, and order history. The solution is basically it put a gateway in front of set of microservices and use application layer 7 routing to route the request to internal services. With this pattern, the client application only need to know and communicate with a single endpoint. If any internal services is changed, the client does not necessarily require any updates. It can continue making requests to the gateway and only the routing changes. So this pattern is the ancestor of API gateway pattern. So we should evolve our architecture with applying new microservices pattern in order to accommodate business adaptations, faster time to market, and handle larger requests. Let's see another example to understand this design pattern. We'll see a real world scenario when we want to support multiple instances of same services and also have multiple version of the same services. Elasticity is the key in cloud computing. Services can be spun up to meet increasing demand or spun down when the demand is low to save the cost. The complexity of registering and unregistering service instances is encapsulated in the gateway. The client is unaware of any increases or decrease in the number of services. Service instance can be deployed in a single or multiple region. This pattern can be used for deployment by allowing you to manage how updates are rolled out to the user. When a new version of your service is deployed, it can be deployed in parallel with the existing version. Routing lets you control what version of the service is presented to the clients, giving you the flexibility to use various release strategies, whether incremental, parallel, or complete rollout of updates. Any issue discovered after the new service is deployed can be quickly reverted by making a configuration change at the gateway without affecting the clients.
What the hell are you talking about?
So friends, let's understand the use cases of this design pattern. In which scenario we can apply this design pattern? Let's understand that. Use this design pattern when you have multiple disparate services, when you have multiple version of the services. Elasticity is the key in the cloud computing. Services can be spun up to meet increasing demand or spun down when the demand is low to save the cost. Multiple version of the same service. This pattern can be used for deployment by allowing you to manage how updates are rolled out with the user. When a new version of your service is deployed, it can be deployed in parallel with the existing version. Routing lets you control what version of the service is presented to the clients, giving you the flexibility to use various release strategies, whether incremental or parallel, or complete rollout of these updates. Any issue discovered after the new service is deployed can be quickly reverted by making a configuration change at the gateway without affecting the client. Client application only needs to know about a single endpoint and communicate with the single endpoint. The gateway routing pattern is useful in this scenario where a client is consuming multiple services. If a service is consolidated, decomposed, or replaced, the client doesn't necessarily require updating. It can continue making the request to the gateway and only the routing changes.
This is not rocket science.
Okay, friends, now let's see some of the advantages that gateway routing pattern offers you. This pattern is useful when you want to expose multiple services on a single endpoint and route to the appropriate service based on the request. The client application only need to know about a single endpoint and communicate with a single endpoint. Use this pattern when you have multiple disparate services. It allows multiple instances of the same services sitting behind the gateway. It also allows multiple versions of the same services sitting behind the gateway.
You're goddamn right.
Friends, now let me summarize what we learned in this video. I gave you an introduction of gateway routing design pattern. Then we saw real world examples of gateway routing design pattern. We understood the use cases of gateway routing design pattern in the scenario where the gateway routing pattern can be very useful. We also understood the benefits of gateway routing design pattern. Friends, so let me know if you have already used this design pattern in your project or seen a scenario where this pattern can be useful. Please provide your answer in the comment section of this video.
Oh, wow. That's amazing.
Friends, in the next video, I'm going to cover about chained microservice design pattern. We will learn what is chained microservice design pattern. We'll see a real world example of chained microservice design pattern. We'll also understand the use cases of chained microservice design pattern. We'll see the benefit of chained microservice design pattern. So stay tuned for the next video and keep watching Code One Digest. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.